Hello, our research is about how can you prove the geometrical structure of complex copper solid. Let's go to see that. At the first, here is the structure of our ligand, while here is the structure of our complex. At the first, to know the elemental structure, we need to use the X-ray fluorescence. Okay, from this X-ray fluorescence, we know that our complex contains copper and Salen Ligand. So we have copper Salen. Okay, and also the X-ray fluorescence data techniques that used to identify and qualify the elements that detect the presence and concentration of elements like copper. Here, we use the IR spectrum to detect the functions group of Salen Ligand. As we see here, the CH aromatic, we find it after 3000, and CH aliphatic, we find it before 3000, and the C double bond N, we find it near to 1600, and also C single bond N, we find it at 1230 to 1030. And finally, the CO, we find it between 1000 and 1030. 300. Also, here we find that there are hydroxyl groups. What the meaning of hydroxyl groups, or what that indicates? That indicates that there are hydrogen bonds that form between the OH molecules or between the silane complex by the attraction force over the hydrogen bonds that form between the hydrogen and oxygen. And here is the IR spectrum for copper Salen. As you see, there are differences in peaks. That due to what? That due to the copper metal. Like what? Like the C double bond N. We find it in ligand at 1653. But here we find it in the complex in 1597. And here is HNMR spectra of Salen Ligand. As we see here, the aromatic H proton of Salen Ligand at 6.5 to 8.5, and also the aliphatic proton from 2 to 3.5, and the C and the H that attached to the carbon that make double bond with nitrogen atom at 8 to 9. Let's go to see the HNMR spectra of complex. And here, as we see, also there are difference in peaks that due to what? That due to the copper metal. Here is the ESR for copper Salen. What the meaning of ESR? The ESR is the brief of electron spin resonance or electron paramagnetic resonance. The electron paramagnetic resonance used to study the magnetic property of material. As we know, the unpaired electron means that this complex or this material is paramagnetic. And from this chart, we know that our complex is paramagnetic. And this is the mass spectrum of Salen Ligand. As we know, the mass spectrum that detected by the proposed fragmentation of pattern, and here we see that the molecular ion peak at 269.07. And here is what the meaning of X-ray diffraction. That the device, and here we put the sample, and this is the X-ray tube and the detector. We represent the X-ray diffraction in these like charts like this. Any matter consists of small crystals like the sand, and this crystal consists of atoms, and the atom contain nucleus and electrons that revolve around it. And this is the wavelengths in the signals. The X-ray used to detect the distance between atoms. If the waves aligned, so the signals are amplified as we see. So this called constructive inflorescence. If the waves are in opposite direction, so it's destroyed. This called destructive inflorescence. And here, if the atom absorb energy, so the electron here is not stable until they exit this energy again. So here we can call it as elastic scattering. And here is the X-ray diffraction for copper saline. As we saw the X-ray diffraction for copper saline, this work deals with the senses and characterization of copper complex. As we know, saline is type a shift-based ligand, and this complex is characterized by different spectroscopic and physiochemical methods. A signal crystal X-ray crystallography study that revealed that copper in complex in 5 coordination and adopts in the strapped square pyramidal geometry. Finally, I want to thank you for watching.